Okay. So, can you hear my video?
Chromium, and open the discussion about how we can try to improve the implementation in Chromium. So first, as you know, Blink is a fork of WebGate, which means that we inherited generic font family names from the CSS font module, but also that
Okay, sorry.
Hello everybody, this is Frédéric Wang. In this presentation I'm going to talk about the MathML implementation effort that has happened in Chromium in the past 2 years. But before that I'm going to give a quick introduction. So on the left you can see a photo of me trying to catch up with all the restaurant food that I missed during lockdown. But I'm actually working at Igalia. I've been there for more than 5 years now. And Igalia is a free software consulting company with expertise on the web platform. If you're interested in learning more about Igalia, you can scan the matrix barcode on the right, which will redirect you to the Igalia website. If you're curious about how I generated such a barcode, you can also check out Russ Cox's page. So, barcodes are able to recover from data corruption using what is called Reed-Solomon error correction. On this slide, there are several mathematical formulas related to the original Reed-Solomon approach. For example, you can recognize Galois field, Lagrange interpolation, Vandermonde matrix, and all these formulas are written in MathML. If you try this 2 years ago in Chromium, you will basically see completely wrong rendering. But today you see that the rendering is not decent, and even if there are a few bugs, you can still read the math and understand it. So 2 years ago, we also gave several talks and published several posts in order to announce that we are working on a development branch for MathML and that we plan to upstream it. And now, 2 years later, we are almost upstream all the MathML patches for Moofrog, at least the most essential one. And you can even try a Chrome release with experimental web platform features enabled, and you will already see some MathML rendering. You can also see on this animated GIF some progress that we made. So 2 years ago, we had published this initial roadmap on the mathml.igalia.com website. And so let's take a deeper look at the status. First, we've already implemented all the basic constructions, like text, fractions, scripts, roots, and so on. Perhaps the most serious bug right now is that we're actually not matrix for text, which means that you can see recursive gaps above and below text. Also, we've implemented table support, relying on the table-ng implementation, but there are still a few bugs and alignments, line breaking, and so on that we'd like to fix. Reading styling. So there are various MathML attributes that can be mapped to CSS properties, like colors, font, or direction. For example, on the formula below, you can see that the quadratic formula is written from right to left. However, there's still some bugs like the stretchy operators are not mirrored. We've also implemented automatic utilization of variable via a new text transform property. But for all the kind of math variants like fracture or double stroke, you'll still have to use code point instead of the MathML attribute. And finally, for people who are familiar with more math styling, you've probably already heard about the inline mode and display mode and display style and of course, the scaling down of text inside scripts. So they are quite complicated rules, but we have still been able to implement them in using some new CSS properties. So you can check these quadratic formulas, and probably you can see the difference. And then in MathML 3, we have this big table describing the default properties of operators according to their code point and their position inside the expression. So we've been able to implement a compact form with various properties. On the formula below, for example, you can see the default spacing of the equal sign, or that the under-over limits are moved according to display or inline style. And similarly, the operators for the summation symbol can be drawn bigger or smaller, depending on the style. And finally, there are some properties related to stretchy operators, which I'll mention later, like stretchy and symmetric. So regarding stretchy operators, so we first had to implement this low-level shaping of stretchy operators using what is called the open-type math table. And this was used to implement radical symbols as well as large operators that already mentioned in previous slide. But also on this slide, you can see some stretchy braces, vertical and horizontal. And we also implemented that. One of the most serious issues that we have is that the min-max content weights cannot be calculated accurately. So until we have a new layout approach for layout ng, we'll still have to live with these excessive gaps inside formulas. Finally, we also have what is called embellished operators. You can see that on the formula below again. For example, the k times over the horizontal brace is an embellishment. All the tasks. So far we've mentioned only what was on the original roadmap. But after discussion with people and after experimenting a bit more, we realized that new tasks were needed. We don't plan to finish all of them before shipping, but at least I think it's interesting to mention them and see if there are some that are very important or not. So several ideas were related to better integration with HTML and with the web platform in general. Some of the features were implemented, but more controversial ones were postponed for now. Similarly, we had some feedback from the math people, so to implement different MathML features or different math layout property. Again, some of them were implemented, some others that are more difficult or postponed. Maybe the most important one again is ink matrix that I already mentioned. Regarding styling, again, we have this idea that we want to make MathML compatible with CSS. And so we want to improve integrity. In order to do that, we had to decide how MathML would interact with various CSS properties. We also tried to implement MathML style features as CSS, as already mentioned. So again, if you check this slide, I'm not going to give the details, but you can see that we implemented some of them. Others were more complex, like, for example, you can imagine that line breaking is quite complex, or vertical writing mode. So for now, this is postponed. During the discussion in the intent to experiment thread, we had this idea of this question about how we would handle accessibility. So what we did was essentially to expose enough information so that assistive technologies on Linux and macOS can actually read it. Essentially, we try to reach parity with Gecko and WebKit here. On iOS, Chromium is using WebKit, so again, this is already implemented. But for other platforms, it's not really clear how we would implement it. So we know, for example, that in Jokes and NVDA are actually using this MSAA API in order to retrieve the raw MathML code. But it's not clear how to do that in general for the platform. So if Google or Microsoft developers are present, we are happy to hear what's the plan on Android and Windows and see if we can help. Finally, last but not least, we have made a big effort on interpretability and robustness. Just to mention one thing, we rely on this MathML core specification, which is covered by around 2,500 web platform tests now. And we have also been promptly fixing issues reported by users like crashes and assertions. And so we have, you can see several points on several items on this slide, and obviously all of this is really instrumental before we send the intent to ship.
Okay, so now I have a couple of demos. Some of them are actually already presented in previous BlinkOns, but now I think it's interesting to see how they actually look like now that we have upstreamed the code. The first demo is a Mozilla Test, which is basically a table with various formulas in a row. So on the left-hand side, you have some images, which are basically how the math should look like as rendered by tech. And on the right, you have the MathML equivalent rendered in your browser. And you see that even if there are still a few bugs, the rendering looks pretty okay now. Then we have this demo for a custom Latex element. So this page contains several mathematical formulas, and if you actually check what's the source code, well, what's the DOM in the expector, you can see that there are MathML formula, but these are inside the shadow root, and it's a shadow root of the LaTeX custom element, which itself contains the source code of written in LaTeX. Then we had this example for mixing MathML with HTML or SVG. So in order to create quiz or to create some schemas, and because you can actually put SVG inside Canvas, you can even create some nice demo with WebGL, for example, if you want to create some three-dimensional representation of schemas. We also had some demos related to CSS. So here is an example of a formula rendered by, with a default style. And then you can see you can customize with a different font family or adding some padding, border matching to some elements, or changing the CSS direction. And for this one, we already mentioned that there are rendering bugs for now related to the mirroring of Stretchy Operators. Another interesting thing is to override the display of MathML elements. So now it's possible, for example, to override the display to use Flexbox or Grid, or you can even use your own CSS layout API to create your custom layout. When I wrote this demo, I think I was not really able to find how we can specify baseline alignment with a CSS layout API, or at least it was probably not implemented yet in Chromium, so I still need to come back to this demo and see if we can improve it. And last but not least, there is this accessibility demo. So here you have a nice formula giving an approximation of the square root of 42. And here is how it is read by Linux, by Orca on Linux.
13 superscript 2 minus 42 times 2 superscript 2 equals 1 right double arrow square root of 42 root end almost equal to fraction start 13 over 2 fraction end equals 6.5.
Okay, and this is how it is read by VoiceOver on macOS.
13 squared minus 42 times 2 squared equals 1 square root of left parenthesis null right parenthesis end of root almost equal to fraction start 13 over 2 end of fraction equals 6.5 math.
So probably you heard some bugs in the way the formula is read, but well, some more bugs related to the screen reader and the assistive technology rather than how we actually expose the MathML code. And I think that's also, if you have questions, I think we can now discuss. Thank you. Okay, people, I hope you can still hear me. So if you want to, we have 10 minutes for discussion, I guess. So if you want to join, you can click the join and with audio and video, I think. Or you can also ask questions on the chat and I'll try to reply.
This is a great presentation. I have one question that's just, I guess it's a nit. On one of the slides, you had x squared over 6, and the 6 was aligned to the center of the x squared. Is that what LaTeX does, or does LaTeX put the 6 under the x?
Wait, what's the goal? I need to find this.
There was an integration. I think there's a integral with x squared over 6 inside of it, I think. Or maybe it was a summation.
Do you remember which slide it was?
Maybe halfway through.
One? Flexibility demo, maybe? Oh, I'm not sharing my screen, sorry.
Yes, I just like I'm just wondering if that's an example where the model where you found it?
Yeah, is this one?
No.
Okay, let me try to remember which slide it was. So what was your question? Your question, sorry.
So there was on the numerator of a fraction there was x squared, and on the denominator it was 6. This one, or pi squared, it was pi squared. Mm-hmm. So you see how the 6 is centered to the pi and the x and the superscript for the 2?
Yeah, I think that's how LaTeX does.
It does? It also does the same?
Yeah, I think so.
All right. So in general, do you think when there are no more bugs that the rendering model is equivalent to LaTeX, or are there some intentional differences?
Well, normally it should follow the same thing as LaTeX, because most of the things are relying on the open type math table from Microsoft, which is itself based on, or it's basically a generalization of LaTeX. But sometimes in MathML 3, because we're also writing on MathML 3, sometimes something may be different, and it really depends on how you convert text to MathML. Sometimes there can be some different things. So, well, I don't have a concrete example here, but yeah, probably you can see differences. And also the other thing is that probably we are only implementing a subset of MathML. So for now, I'm not sure we can do everything. For example, with tables, I mentioned that we still have some issues. So probably with tables, you'll see some differences. I guess if I come back to the slides, I'm already mentioned the issue with ink matrix. You can see that probably that the text, there is too many gaps above and below. And also, I guess on this matrix, the centering is probably incorrect. Or maybe we don't see it here. Yeah, but sometimes I think the centering is incorrect. So yeah.
I'm curious if Don Knuth has noticed this work and what he thinks.
I don't know. I noticed that Fernando shared the screenshot about how LaTeX renders p² minus above 6, and it seems it's the same in the chat. So yeah, and really, Donald Knuth, I'm not sure if he's aware about the MathML thing, if he has commented on it, so I don't really know.
I wonder if in the future it will be possible to write an entire research paper in a web page pretty easily.
Yeah, so there is this project, maybe you know Archive, the Archive project, which is where you have you can put some PDF of your papers. And I think there is a research project in Germany. I think it's called Archive XML or something like that, which tries to convert all the papers from Archive into HTML plus SVG plus MathML. And yeah, and I think that's interesting because I'm not sure I can find it. Yeah, they're trying to generate all the thing and see if we get the same result. Probably they're not able to convert everything right now. One of the issues with LaTeX is that you have many packages, so it's difficult to be able to convert everything. But hopefully, we'll be able to see more people sharing papers in HTML and MathML.
That's sort of the question that I had was like okay, because there are some JavaScript LaTeX parsers at this point, right? So like I don't know, MathJax and KTax and things like that. So one thing that would be, and you're right, like they do simulate a lot of the LaTeX. I mean, some of the LaTeX packages, because LaTeX gets very crazy in terms of types of packages that they have.
Yeah.
But do you see this sort of like as a way to support like those libraries? So basically the libraries be able to, instead of generating like SVG or having to import fonts or do stuff, be able to like still support the high level LaTeX packages, but then use like MathML instead of re-rendering everything, which is what they do now, right?
Yeah, so I think actually both MathJax and LaTeX actually are able to generate MathML. I think, for example, they're used for accessibility, but by default, I think they run the SVG. And well, I'm not sure for now if they have done a lot of work trying to test native rendering with MathML. I think for now they're more focusing on SVG. But I guess your question was more about the high-level package.
No, it's the ability for people to extend in a way, right? Because that's sort of the reason they end up with the SVG solutions, because eventually there will be some package in LaTeX that does like, you know, music notation or some weird stuff, and then they have to or tables or some other types of tables or whatever, right? So they end up in the situation where they have to re-render a bunch of stuff.
Yeah. I guess one other thing also is that the thing that was mentioned in Archive XML is actually, I think, not a JavaScript library. It's just basically relying exactly on it's basically an extension of the LaTeX parser. So it's actually running on LaTeX, and you can generate statically. It's not this one, but you can generate statically the HTML and MathML and so on. So I guess I'm able to support more packages. But yeah, if it's written in JavaScript, I guess you'll have to do a lot of things to support all the LaTeX thing, and probably you're less likely to be compatible. So yeah.
Well, with regard to like extending, depends also like what you mean. So MathML core is geared toward orienting it toward the platform, as a lot of Fred's things show, like explaining how it works with CSS, giving you the power to like integrate other bits of the platform, including like Houdini stuff. So I think there are a lot of opportunities there. MathML core level 1 doesn't get into it, but we're keen to get past that initial point so that we can get to level 2, where we also want to talk about enabling Shadow DOM and like on MathML, and having a way forward for MathML to extend as well. We actually did some prototyping and have some sort of proof of concepts that if you look back, you can see there's some interesting things there.
Yeah,
this was, if I can just add a little bit of color, this was one of the sort of big problems with the sort of MathML implementations previously, is they like didn't really, you know, integrate with CSS at all. You know, one browser took one decision, the other browser took the complete opposite decision. And so like the, you know, folks at Galley have done like a great job like actually specifying what the rendering model is, which like didn't exist before. Pretty much it was like left up to an exercise for the reader. And you know, like Fred's demo is like showing that, you know, you can just say display grid on a MathML element and that will just work, is a huge step forward compared to what implementations could do previously.
Yeah, I think that was sort of my question. I think the better integrated it is with the rest of the platform, the easier it is to extend it, right? Which means it has more useful use cases, because there's no reason to jump out of it in a way, because it integrates well with other stuff. That's amazing.
Yeah, like another sort of area was just like, you know, putting like just basic like borders on elements would sort of like break rendering in other engines pretty substantially. And so, you know, Frédéric and his team sort of went through and like, you know, wrote tests for all of the stuff that, you know, borders actually apply how you would expect. So they did a really great job there.
Yeah, I think with Latex, some people just basically try to tweak the spacing and add something. So now that we support border, it's easier for them.
And people get very picky about fonts and stuff like that. At least I do. Like I was looking at the presentation, I said, like, is this the right? Like, no, it's ridiculous, right? Completely. When people do that. Anyway, very good job. I think it's amazing. It's really cool.
Thank you.
Thank you, Frédéric. Really good job, good presentation.
Thank you, Dominic.
Do you think it'll be a ton of work to get full interop on all 3 browser engines?
Depends what you mean full interop. So I don't remember the score of MathML core. The thing is that now well, as Jan mentioned, is that in the past there are not really clear rendering models. So we have added a lot of web platform tests related to CSS compatibility in particular, but they are not really passing in Firefox and WebKit for now. For example, I think WebKit and Firefox don't have this border and padding support. So yeah, that seems if we want to focus on this integrity effort, I think we should focus on all this CSS stuff.
Yeah, so I think that like the sort of interesting thing here is like if we had all of these web platform tests, let's say 2 years ago, the interop score would have been like truly miserable on the 2 that were shipping native support, and it would have been effectively 0 for Chrome. So today, Chrome will score very, very high. It's not all the way there yet, but even along the way, there have been several improvements to the other engines. So I think that there is a lot of work to do, like a lot of the short stroke stuff that was introduced in core, but I think it's trending really well, and it would be really worth spending some focus time on making that really great.
Okay, thank you, everybody. I think we're running out of time because there is the next session about rendering happening now, I think. So yeah, thank you, and we can talk later. Bye.